Um, did you guys have any questions about the individual preparation at all?
I don't think so. I did it all this last weekend, so it's like kind of a blur to me, but I don't think I had any.
Yeah, it was not too bad. It was basically kind of just slope, which is, I feel like you learn that a lot while when you're little. I don't know. You guys are older than me, so you're kind of a little bit more out of high school, but it was still pretty fresh on my brain. But.
Yep, good old slope y-intercept model.
Okay, so I guess we can just open up the quiz. And then just another note, I just haven't had a chance to get all the describe my data put together yet, but I'm planning on doing that tomorrow. So I'll get that to you guys by tomorrow night, and then we'll have Friday and a little bit of Saturday to kind of exchange and change it up however we need to. But does that sound like an okay timeline? Sorry, I had a big test today that I had to like study for on the 4th of July. It was awful. But now that that is over,
Nope, that's all good.
I can
Not a problem.
get going on that. So, okay. I'm almost ready. Okay. And then I'm just going to pull up the... Sorry, I'm just pulling up the data too.
You're good.
Okay. Let me go ahead and read the first one. Are we all good to start?
Yep.
Okay. Are you good, John?
Yeah.
Okay. Question 3. Given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept? That's the 2.0.
That's what I got. Yep.
Yep. All right, next question 4. Given the linear regression equation y equals 2.0 plus 1.8 or 1.5x, what's the slope? So that's the 1.5.
Yeah,
that's what I heard.
I agree.
All right. Question 5, given the linear regression equation y equals -3 plus 0.25x, what is the predicted value of y when x equals 16? So that's going to be 1.
Yep, that's what I got.
Yes.
Did you do that in your head, John?
I did. Well, basically, you know, it's 1/4 of 16.
Because of the
so
4 times, yeah.
Yeah, just as soon as I saw 1/4, I was like, okay, 16 divided by 4, and it was pretty easy.
Okay, for the next 7 questions, use the data file math self-efficacy. Be sure to use the confidence data for the explanatory variable and the score data as the response variable. Question 6, make a scatter plot of the math self-efficacy data. Of the 3 data shapes introduced in the reading, which shape best describes these data?
Okay.
This is where doing that quantitative inference thing will be helpful. Oh, I can't believe I just closed that out. Doggone it. All right, there we go.
Scores are a response. Is that what it says?
Yes.
Scores are a response. Okay.
Which shape best describes? What's the shape? I think a hot dog is the best shape myself.
I think I would agree to that.
Yeah, it's not curved enough for a banana.
Uh-huh.
Yeah, it's not quite wide and round enough for a hamburger.
Okay. Okay, question 7. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model this data?
I think we'd be able to say it's appropriate, wouldn't we?
Because it looks like it's positive and linear.
Correct.
Yeah.
Yeah, I think it's appropriate because it looks linear.
Okay. Question 8. How many observations are in the data?
Oh, I've minimized it just a sec.
All right, I've got to find where that they talked. I'm not remembering.
I know, I'm trying to remember where. Is it just the count of things?
I think it would just be like your n, wouldn't it? Like how many is there?
That's what I would think. So is it just all the variables, like the explanatory and the response variables counted up together? Or is it?
We
I
don't,
don't know.
do we have it? I don't see an N on here.
Yeah.
Yeah,
So,
there's not an n.
see if I go shift N down. It's like we have 141. No, 139 rows.
That's what I'm looking in the reading, and it doesn't even
It doesn't say anything about observation.
talk about an observation value. Yeah.
Well, the only thing I could think an observation value would be is, you know,
Your count is all I'm thinking.
right, variable X and variable Y. So we have 139 variable X's and 139 variable Y's. So I would think one of each equals an observation.
That's what I think.
Yeah. I was looking, I was Googling it, but
You find anything?
not really. It's not being very helpful. But that's what I would guess. So
I looked for the word observation in the text and it didn't say. So.
yeah, I did that just barely too. So how many were there, John? Sorry, you said there were 137 in each?
139.
139.
Oh, 9. So would you add them up together, or is that the total?
Well, that's a good question, right? So do we consider each one independent, or do we consider a pair an observation? So
I think a pair is an observation, but I don't.
That's what I'm assuming.
Yeah, that makes sense.
But like I said, I couldn't remember anything from.
Well, it didn't give anything, so.
Yep.
Okay, we'll try that then.
All right.
Try
Question.
39?
Yep, that's what I'm putting. 139.
Yeah. Okay.
Oh, whose turn is it? Is it mine?
I think it is yours.
Okay. What's the y-intercept?
Um.
And the y-intercept is
18.69. Yeah.
Really?
Is that not what you got?
No, I did something wrong apparently.
You have them in the right columns. I did that. Does your explanatory variable start with 4.34?
No, my explanatory variable X is 50.
Okay, so you got those swapped.
4.34.
Yeah, so those are swapped is what's wrong.
Now why do I have them swapped? All right, hold on a second. So you took confidence rating mean as the first row and score as the second row.
Yeah, in the information
Yes.
before number 6, it tells you to do that.
All right, I missed that. That probably explains why. So let me try this again. Yeah, a very different output. $18.690.
Yep.
Okay. Now I'm on track. All right. Thank you. What is the slope? 12.695.
That's what I got.
Yep. Catherine, is it your turn or my turn?
Sorry, I totally was not following the flow. I was just sitting here waiting.
I can go. Question 11. What is the predicted value of y when x equals 4?
I got 69.470.
That's what I got.
Yep, that's what I got.
Perfect. Okay, question 12. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Round to 3 decimals. Hint, because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
Oh, so that's taking 6 in that equation instead then, right?
I would think so. Or is it saying you take the largest? Yeah, I guess the largest is 6 in our data, so.
Because that's the scale.
Mm-hmm.
So we take 6 times the 12.695 and add the 18.
So if I got this right, 94.86.
That's what I got.
That's what I just got.
Question 13. How many explanatory independent variables are present in a simple linear regression? Is that just one, isn't it? Explanatory and one response?
Yeah, I would say 1. We know you can go to more than that, but I think the simple one is just 1.
Yeah. I would agree.
Then 14, how many response or dependent variables are present in a simple linear regression? Once again, I think it's 1.
That's what I think.
Okay. Question 15. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect include hat size, circumference of the hat, and length of the major and minor axes, meaning the company wants to predict the size of hat given the circumference. What is the response variable?
So that would be the size of hat, because it's what's being predicted.
Yes, I would agree, I think.
Let's see.
Yeah, I agree.
Okie dokie.
All right, let's submit and see how we did. Nice. 100%.
Good job, guys.
Yay,
Awesome.
us.
Okay, so I'll get you that describe the data stuff tomorrow night, and then we should be good to go for the week.
Okay. Is there anything else we need to be working on? Is that
I don't think so as far as that goes.
I think that's it. And then the next one is the make inference. Is that
Yeah, the
step
next
after that?
Yep, there's the make inference and take action. I haven't looked at. I've got to look at the details on what's required and all that good stuff.
And then I'll compile it all into the PowerPoint for our end show. I went and printed out what was required for the end PowerPoint, and it looks like it's a combination of all the steps in between, like the graphs and different things. So
Awesome.
anyhow, perfect. Okay, well, so Monday, same time.
Yeah.
Okay.
Yep, sounds good.
Have a great night.
You
Thank
too,
you.
guys.
You too.
Bye.